Good afternoon, everybody. My name's Simon Hatton, and I'm the current chair of the Offshore group, and I have the pleasure of hosting today. Just a few things before I hand over to Shailesh, our speaker for the day. For those of you who are already members of the group, you all know that this is the third webinar that the Offshore group have been involved in, and I thank you all for attending. This is actually the first joint event that we've done with the Hazardous Industry Group, and I thank the Hazardous Industry Group for doing this with us, and they've been a fantastic support throughout. And Shailesh, your speaker, is a member of that committee, and so I thank him in advance for what he's about to speak about. Hopefully, all being well, that this will be the first in a series of webinars that between the two groups we will look to put on for you. But obviously, that will be dependent upon the feedback we get from yourselves. So as Ben rightly said, throughout the session, if you do have questions, if you do have comments, please do take the time to raise them. And also following the event, you will get the opportunity to raise some feedback and to generate some feedback coming out of the event. And what I would say to you is that will be read and analysed by both ourselves and the Hazardous Industry Group. So please do take the time to feedback to us. Your opinion genuinely does matter, and it will genuinely determine what we look to do moving forward. So if you could take the time to do that when the opportunity arises, we'd be very grateful. As Ben said, please raise your questions throughout the event, and what we will do, we'll do the question and answers at the end. I'll pose the questions to Shailesh and obviously and hopefully try and get the answers that you were looking for. My final thing to say, and I'm really keen not to take too much time away from Shailesh, is just to say this: everybody who's dialed in today, you've all done so for a reason. I don't know what that reason is, but I would imagine there's something within the content that you are hoping to learn, whether that's a question you've always wanted answered or something you wanted a bit more insight into. So you do have the ability to raise questions. So please, if there is a question that you have that hasn't been answered, especially towards the end of the presentation, please do take the time to raise it, because I would hate for any of you who have taken the time to dial in to leave today's session without the answers you were looking for. So without further ado, I will hand over to Shailesh, who will take you through his presentation.
Good morning, good afternoon, and good evening, my listeners. First of all, may I please thank you for your time and the interest you've shown in this presentation. As for the title, it is about awareness. It's not the full Monty, as they say, for process safety, but it's a beginner's guide. And in this one, I'll be using various standards. Now, the first picture I have is a small clip. Some of you may have seen it. Apologies to those who have seen it before, but this gives you a clue as to what we'll be talking about later on. There's no sound on it, so please don't turn up volume on your screen, please. There she comes again. Hallelujah. So this is going back to the, so the question I'm asking is, what do you think led to this incident? Now, I don't expect an answer straight away, but it's to do with electrostatic charge. And in process safety, this is a source of ignition. Moving on. Now, my objectives for this session is to define what process safety is, explain the difference between occupational safety and process safety, describe the 10 pillars of compliance approach, which I'm going to follow. There are various standards, as people may be aware. There's the OSHA Process Safety Management Standard. There's also a very good Energy Institute guidance on process safety framework. But for the purpose of this session, to keep it simple and very much targeted, I'm going to use the 10 pillars of compliance approach, which is applicable to any process safety management system. It's a very basic and simple process, and this is the approach which the UK regulators, Health and Safety Executive, have followed. So when they come on one of the sites which are governed by Control of Major Accident Hazard Regulations, they follow this approach. So I'm sticking to that one, makes life easy for us. I'm going to outline consequences of process safety failures with a few examples, and I'm going to highlight the key part played by human factors in achieving high process safety standards. So thankfully, human interaction is very good, and it's very essential in achieving process safety. Most of the stuff that I'm going to talk about will not come as a surprise to you. You already do that. as just explaining the link. What is process safety? Process safety generally refers to prevention of unintentional releases of chemicals, energy, or other potentially dangerous materials during course of a chemical process that can have a serious effect on the plant and the environment. Process safety, for example, involves prevention of leaks, spills, equipment malfunction, overpressures, over temperature, corrosion, metal fatigue, and other similar conditions. Process safety programs actually focus on design and engineering of facilities, maintenance of equipment, effective alarms, effective control points, procedures, and training. In other words, everything we do on the actual hardware, on the equipment that we have. It's sometimes useful to consider process safety as an outcome or result of a wide variety of technical, management, and operational disciplines. They all come together in an organized way to give us a safe outcome. The figure next to it gives you like a very broad view of what's involved. And the heart of this process safety wheel, as I like to call it, is management leadership. And just to stress that point, let's talk about the differences between personal safety, which I would say is occupational safety, and process safety. So if we look at the typical safety triangle, hopefully you would have seen this. So there's health, environment, and safety, the same triangle on both sides. But in occupational safety or personal safety, we tend to concentrate more on preventing harm to people, on people's health and to people's safety. For example, we won't be running dangerous machines which chop off people's fingers without inadequate guarding, etc. But in process safety, we concentrate more on preventing losses or long-term harm to the environment and also the safety. So we're talking about fires and explosions here. Again, how do we do this? What are the little indicators of danger? That's my favorite saying. What are little indicators of danger in personal safety and process safety? So if we look at the figure, the triangle there, so examples of getting personal safety wrong are injuries, manual handling, exposure. And in process safety, the examples could be fire, explosion, pollution, etc. If we look at the typical triangle, the focus on personal safety is picking it up very early on. So you get lots of near misses, you get lots of minor incidents, and if you don't do something about it, you could get serious incident and heaven forbid a fatality. But in process safety, it's the other way around. Unless you are very much focused on process safety and do your process safety performance monitoring rigidly and rigorously, then until something goes wrong, such as a serious accident or a fatality, you have no clue that things are not running right. So it's very important. And this is one of the pillars of process safety, which I'll explain later on. Moving on, to control the hazard, for personal safety, we should focus on elimination and substitution. But usually it's very easier to say, here, wear this hard hat and you'll prevent injuries to your head. Wear this safety goggles so your eyes will not be taken out by a corrosive chemical. So these are administrative and PPE, and people often go for these controls. And they are in the hands of the frontline workers, operators, and supervisors. But whereas in process safety, notice, responsibility of hazard control is hands of senior management and engineers. So elimination and engineering are the first preferred choices. PPE will not stop a process safety incident. And that's an important difference. But to be quite frank, there's no dividing line between the two types, and we must get both of them right. Overall objective is in an industrial setting, in a work setting, you don't want to harm the people, you don't want to burn down the plant, and you don't want to cause fire and explosions or severe environmental pollution. I hope that is pretty obvious for all of us. So here are my wonderful 10 pillars of compliance. So this is a list of 10 pillars of compliance, which is followed by the competent authority within the United Kingdom. So it consists, the competent authority comprises of the health and safety executive, who look after safety and health, and the environment agency, who look after obviously environmental matters. So here you see a little cartoon where Joe tried a plastic bag. His purpose was good. His purpose was to prevent things falling into this open vent whilst the tank was under maintenance. But actually, it caused a vacuum. And the tank actually looked like this. That's severe damage. Thankfully, there was nothing in the tank, but we prevented a loss of containment there. And this could quite easily happen if we don't pay attention to process safety. So my first pillar, and these are in no particular order of importance, they're all important and equally important. The first pillar is safety management system. The second pillar is aging plant. The third pillar of compliance to get good process safety is competence of people. Fourth pillar is safety instrumented systems. The fifth pillar is overfill or prevention of overfill. The sixth pillar is secondary and tertiary containment. Seventh pillar is internal emergency plans. Eighth is external emergency plans. Ninth is process safety performance indicators, which I just mentioned in my previous slide. And 10th pillar is safety leadership. I acknowledge that I've taken these cartoons about poor Joe from iChemist's book, An Engineer's View of Human Error. So when the competent authority comes to our site, they do an intervention visit, and they give us the following sort of rating. And the rating is described. So over here, the highest score of 50 is not good. The lower the score, the better it is. I've rarely seen scores of 10 or 20. Most of the time, people are between 30 and 40. It's defined here. I don't intend to go through this because you'll have a copy of the slide at the end of presentation, but this actually defines what the competent authority will rate you against based on what they find. And they have a lot of guidance. It's not as if they're coming in and just hitting you with an inspection. They have very good guidance on each pillar. And I will be putting in the references for you to look this up in detail, should that be of interest to you. So pillar one, what's this about? Safety management system is your daily bread and butter of process safety. So we are looking at permit to work systems, safe systems of work, operations, maintenance procedures, management of change, hazard recognition and reduction, safety reports in case of the UK legislation, bow-tie risk assessment reports, hazards and operability studies, etc., etc. This is a core of process safety. If we haven't got safety management that is defined, trained out, implemented, and audited, and monitored for any failures or trends, then process safety, achieving good process safety is going to be really, really difficult. Another theoretical question for you: which of the following disasters were result of poor or total lack of management of change? And often, many companies do fall down on management of change. Either they don't recognize it, or they don't do something about it, or they don't communicate it, or they don't complete it in a structured manner. So Flixpro 1974, 28 people unfortunately dead. This was a wake-up call for the chemical industry in the UK. Yeah, management of change, which didn't go to plan. Piper Alpha more recently, again, permit to work system, things were changed, not communicated out. Unfortunately, quite a large number of people met with death. Bhopal toxic gas tragedy in 1984. It's estimated, and the figures tend to vary, but I've just chosen a middle figure that I came across in my research. 8,000 immediately dead. 8,000 people immediately dead. And this is, again, management of change, safe systems of work, permit to work, lack of maintenance, safety systems taken out for maintenance at the same time the process was running, and so on. Do you think, now this is a question for you to study, your own homework. Do you think your organization is good at managing change? And if you think yes, do justify it. And if you think no, then do something about it. Right, the second pillar is aging plant. An aging plant, just by the way, this tank that you see a picture of, it's been decommissioned, it's not a live tank. But aging plant is not about a rusty old piece of kit. Aging plant is defined in the HSE guidance about what do you know about that condition and how that's changing over time. And is it still operational? Has it breached its sort of design parameters? Say, for example, if this tank, for argument's sake, was designed to be 6 mm thick, and when you do your cleaning, repair, maintenance, and inspection, and you check that the design parameter was that it should not be used after it's 3 mm thick, and it's reached 2 mm, then it's aging plant, it should be taken out or done something about it, replaced. There are well-known corrosion mechanisms that engineering departments in your companies, in my company, deal with daily and take actions to prevent or minimize this. And the ultimate aim of process safety, I would say, is 2 words: prevent loss of containment. If your toxic, hazardous, corrosive liquid is in containment, there's no problem with it. The moment you lose it, intentionally or unintentionally, then the consequences arise. So in case you're wondering, what causes plant to age? These are some of the reasons, not an exhaustive list, but you have corrosion, you have stress, you have erosion, you have fatigue, you have embrittlement, you have physical damage. In concrete, which you think is more permanent, you can get spalling due to atmospheric corrosion or moisture ingress. You have subsidence, you have weathering, your expansion, contraction due to thermal changes, daily weather changes. You have instruments that drift, that no longer show the correct readings. You can have dry joints within sensitive level instruments. You can have detector poisoning. These are only some. There are lots of causes. And to keep on top of aging plant is, again, plant preventive maintenance, understanding what the equipment is designed for, preventing any excursions behind the design limits, and so on. Now, these aging mechanisms can affect primary containment, the tanks themselves, and pipelines, as well as supporting structures. That's also important to understand. If you maintain your pipeline and your tanks, that's not sufficient. You also need to look at what's keeping the pipeline stable, what's preventing it from falling down. Or if it's underground, how do you monitor underground pipelines for corrosion? Do you do regular pig runs? Do you review the information once you've done the tests? Or is it just something on a tick box? So all these things bring up these issues. The third pillar is about competence, and very important that is. When you ask someone, what is competence? And people usually say, oh, it's training and experience, ability to do a task according to standard procedures. Would you call ability to respond under pressure competence? Yeah, definitely. Here is poor Joe again from the same reference. Joe left the job for a minute while draining water. This is a typical operation in gas industries, oil industries, and even chemical industries. So what you do is you remove the water, hopefully not on the floor as Joe is doing here. But in this case, Joe left the minute, do something, maybe he was called out or he had some other task to attend. And by the time he came back, there's a big fire roaring there because it's a flammable liquid and just caught fire. So in the COMA regulations, control of major accident hazard regulations, which apply in the United Kingdom and across Europe as SEVESO regulations, competency is actually very important. And the competency is not just training, experience, and how they perform. It starts with recruitment. Are you recruiting correct candidates? Ask yourself, get involved with the HR. It's not just recruiting a person, you're recruiting a person with the right attitude and the right skills. And if they haven't got the skills, how will you go about providing those skills? All this and much more. The ability to carry out, in my opinion, safety critical tasks correctly every time is the key process safety requirement. So just to give you some more homework, which of these 3 options do you think is a safety critical task? Safety induction of visitors to your site, line breaking for maintenance. So this is the operational pipeline I'm talking about, or wearing correct personal protective equipment. And the clue to the answers would be, what is the consequence? If the visitors are not inducted, are they going to go and have a quiet cigarette in a highly flammable and toxic atmosphere? Just a ridiculous example. Or when you're breaking line, is the line under pressure? And what is the liquid which will come out? What is the consequence? So these are the questions you ask. And there is definite guidance on the HSE website in the UK on safety critical tasks and how do you go about measuring it? How do you go about identifying it? What do you do about it? I would urge you to read the guidance. Next one is about safety instrumented systems. Prevention of loss of containment and fire and explosion is based on reliability of safety instrumented systems, or the acronym in our wonderful industries, SIS. An example of such equipment is shown here, where this is a level gauge which alarms when the tank capacity is reached. So we are filling up this tank, it reaches preset high level and it alarms. But is that sufficient? Have a look at your own safety instrumented systems. If it's just alarming and it's relying on someone to listen to the alarm and react to it, A, do they have sufficient time to do that in? And B, can it be further automated? And wonderful, it would be wonderful and very good for process safety to prevent loss of containment overfilling if the radar not only alarms, it also actually shuts down the inlet to the vessel. Makes sense. You are going to design the hazard out. You have overfilled, fair enough. You shouldn't have done that in the first place if your operators were competent. But if the worst happens, what is your layer of protection there? Another example is in oil storage industry, interceptor pollution probes, which alarm, and in good cases, with good design and with good investment, it actually shuts down the final valve. So you not only know something is wrong, but you also have an assurance that the pollution, the polluting liquid is not going to enter the public water courses and kill fish and aquatic environment. My favorite is pillar 5. If you look at most of the incidents, they are due to overfill, at least in our oil and gas and storage industries. So here is a clip from one of the CSB incidents. Overfill of tank is one of the most common process safety event that might lead to fire, explosion, or severe consequence. The factors we must get right is, are people competent and following, say, for example, route cards, which say, okay, now I'm going to divert the flow from the ship to tank number 1. Tank number 1 is nearly full, so I need to go to tank number 2, but before I do that, I need to shut these valves in that order. So that is clear procedures, training, and experience. If you don't have that, very easy to overfill because you might route your ship's input to the wrong tank, which is already full. So it's got nowhere else to go. It will just come out from somewhere. Use of maintenance systems to inspect and proof test all safety critical plant and equipment. So going back to safety critical plant, how do you identify it? There is some really good guidance on the Energy Institute website, and I shall provide links when the final version of this presentation is uploaded for your access and use. In the UK, we have what's known as a containment policy scorecard. That actually forces us as operators to look at, do we have primary containment? Do we have secondary containment? Do we have tertiary containment? Are these good enough or not? And then these scorecards, when they are filled in, are reviewed by the Environment Agency and the HSA. And then you can have a plan if you are deficient in some areas to improve it. Unless you measure it, you can't improve it. That's the universal truth. And here's pillar number 6. So we have secondary and tertiary containment. Syria 764, which I mentioned below the figure, is a very good guidance. It's freely available on the website. So please type in Syria 764 guidance and it will give you a link to download this guidance. It's very comprehensive and it's excellent. It is really good practice, I would say. So some of the terms that I'm using, secondary containment. So what that means is you have a tank, for example, the tank here, and if it was to lose its contents for whatever reason, maybe aeroplane strike or something ridiculous, or maybe a valve that's just sheared off because of aging, lack of maintenance, or poor design, then are the contents of this tank going to go all over and pollute nearby rivers, water courses, or are they going to be contained in a bund? So this bund is a secondary containment. So your primary containment is the vessel itself. Secondary containment is the bund. And say, for example, the bund is to be designed to Syria guidelines, which say 110% of the largest tank in that, or it could be 125% of the largest tank in a group. If the bund is not able to contain it, then it can overflow, go through the drains into the water courses. So in such cases, what you can also have is, so this is like a backup to a backup to a backup. You can have tertiary containment. So the sites could be designed that all drains feed to interceptor, and anything going from the interceptor or anything outside the interceptor could be captured on a low-lying lagoon. I understand that it's not possible for this sort of containment to be built on smaller sites, but for the larger sites and proportionate to the loss of containment consequences, whether it's toxic, pollution, or fire or explosion, if you run a hazardous site, then you must provide this or measure yourself. And this gives an indication of how good you are at your process safety management. Tertiary containment is containment of product which is overtopped. Now, there are other scenarios. So if, for example, there is a fire in this pond, is this tank walk figure 1. If there's a fire and it's being cooled down by firefighters from a safe distance. So you got hydrocarbon release in that bund and you got water coming over. So what's going to happen is the bund is going to, even though it's designed to 110% of the capacity, it's going to run over. And running over, hydrocarbons normally are lighter than water. So they will come over and they'll go to wherever they will go. And with the fire, there'll be like a running fire pool going all around the site. That's a nightmare scenario. So again, having these sort of arrangements, and Syria 764 will guide you to more help, detailed technical help. My pillar number 7 is internal emergency plans. So in the UK, we have the first 2 aspects to an internal emergency plan, which is major accident prevention policy. So this is a commitment from the most senior levels of your company that you will take measures to prevent major accident. So major accident is different to a normal accident. I won't call an accident normal, but just to be clear, major accident is multiple fatalities, severe fire, toxic cloud smoke going over public areas, etc. The second tool that's used in internal emergency plans, and there's very good UK guidance, although it's applicable to UK and the parent version Seveso is applicable to all over Europe, there's nothing preventing you from looking at the guidance. The guidance is COMA approved code of practice L111. I shall be providing links to those for you for your use later on. So there's something called PIZ. So PIZ stands for Public Information Zone. So when our competent authority receives a safety report from us as an operator, they actually review it. They do predictive calculations of a fire event. So say we were to have a jet fire or pool fire, how far the thermal radiation will be going and who will it harm. So based on that, they would establish a public information zone. So then there's a legal duty on us as an operator to write to the public who might be affected by whatever happens on our event. And this is very important because if you refer to some of the Chemical Safety Board incident videos, people in the neighborhood really didn't know what was going on in the factory. They thought it's just a normal factory. But when something went wrong there, it actually affected the locality around them, the sites. Another point within internal emergency plans is exercises. Invite your local fire brigade, who are usually the first responders, to come on your site, have a look at what you have, and do some sort of tabletop exercises or even on-site exercises with them to understand how they would respond and what are the things that would make their life easy. An example of this could be if you have fire water mains on your site, which you want to use the fire brigade to use when they are on site because they might not have enough water in their tankers, is to make sure that your hose fittings match what's on your site. So they can very quickly, without delay, connect to that and use your fire water. Emergency procedures, once they are written, should be reviewed. And every time you review it or do an exercise, you should make changes if required. My pillar 8 is external emergency plans. So again, this is specific to the UK. You might have your own regulations. Do check them when you start talking about process safety. External emergency plans, actually, the responsibility for developing these lies with the local authority. And it has input and consultation with all emergency responders. So within the UK, the fire brigade, the police, the ambulance, the Public Health England, the health and safety executive, environment agency, highways authority, water authority, and so on. And also community groups, they all are consulted. So what this means is we as operators give scenarios, what could go wrong realistically, not be ridiculous, but realistically. We give the scenarios to the local authority, and the local authority then consults all the statutory consultees and then works out a plan on how they would, what is their role, what is their responsibility, and it's a legal responsibility within the UK under the COMA regulations that I keep on mentioning. It's a legal exercise for an operator. They must do one every 3 years. So every 3 years, there will be an external emergency plan. As an example, on one of our sites, we have 110 people. And they have different roles. So some are players. So these people are not aware of what the scenario is until the day of the exercise. Then you have umpires who can provide information should the agency ask. So for example, if a fire brigade asks me, where do I turn off electric supply to this area which is affected? Then umpire is a knowledgeable person with the site knowledge who tells them, yeah, you go to this place and that's where you can safely turn it off. And so on. They have observers. Observers are neutral people. They observe, have people followed the plan? What were the improvements required? Was the communication okay? What did go wrong? And what did go well? So at the conclusion, there's like a hot debrief for 15 minutes. Everyone then chips in with their information and say, yeah, that went well. We could improve on this. And then there's a formal cold debrief. This is all part of the regulations under control of major accident hazards. And this is our pillar 8. The aim of this exercise is to validate the plan and continue to improve it. So the moment you think you got a perfect plan, that's the moment the downfall begins. Next, I mentioned the process safety performance indicators. And again, there are very good guidance documents from the Center for Chemical Process Safety in America. Our own HSC has HSC 254, which gives you a full guidance in crystal clear language without technical jargon on how do you go about identifying and setting up process safety performance indicators. So these are the indicators. If you go back to the triangle, if you refer to the triangle which I showed you earlier on, these are the ones which actually will indicate to senior management what my risk controls are doing. Are these effective? Are there any issues with my process safety controls, my risk control systems? And this could be two types. It could be lagging, which means something's gone wrong and you're going to learn from it, or it could be leading. And it's important to understand you can't just have leading indicators, you must also learn from lagging indicators. If you don't learn from your lagging indicator, your process safety incidents, as I call them, then you will never get a true picture. So typically risk control systems are operator competence. So again, one of my first management, first pillar of compliance, safety management system. Operational procedures. Do you have procedures? How do you train your operators against these procedures? Are these procedures audited? Do you do what you say you would do? Or do people develop their own systems of work? Their little shortcuts, which might be good for making the work go faster or completing a job with less hassle, but might not be correct process safety procedures. We have seen examples of Joe leaving unattended draining of the tank. That's a typical one. The procedure might say you will stand by that tank until you drain water and not go away. A moment's hesitation could lead to incidents. So as I said, the process safety indicators could be proactive, which is good practice, such as planned preventive maintenance. So that's very easy to set for you, isn't it? If you have a planned preventive maintenance system, especially if it's computer-based, you know, for the month of April, that's just gone by, you had 30 planned preventive maintenance tasks. And after the month has gone, you look at that and you say, okay, I managed to complete 20 of the 30. My target was 25 as a minimum. So you know that I'm falling behind with my preventive maintenance. So that, again, is an indicator of danger. You're not maintaining your plant. You're not maintaining your plant integrity, and that can lead to loss of containment. So Again, some homework question for you to think about. Can you think of what else would be a good process safety indicator? Last but not the least, as I said in one of my safety triangles, the core of good process safety is leadership. Leadership, by saying leadership, I don't mean managers, I mean the actual senior leaders of the company, the board members, the executive members of the company. Okay, so they need to be fully aware of what process safety is, how process safety is managed, and if there are any breaches of process safety, what is being done about it, and how do you continuously improve your process safety. O&M means operations and maintenance team. They play a key role, and there's an eternal fight between operations and maintenance in most companies that I know of. Yours might be an exception, so my apologies, but most companies, operations take precedent over maintenance. The maintenance person says, you're due for preventive maintenance, I need that piece of kit to refurbish, check, inspect, and reinstate. And operations, no, too busy, need to provide the customer with the goods, go away. That is not the type of dialogue that leads to good process safety leadership. So the senior leadership teams, if the board members actually go to the site and talk to the people and talk to the operators, what are the process safety issues? So that serves two purposes. One is it becomes a two-way conversation, and also it raises the awareness of the process safety operators, the plant operators, who can then relate their tasks to the key process safety failures or consequences, and consequently be more efficient, be more aware. To summarize, process safety is different compared to occupational safety. Process safety relates to safe operation of the plant to minimize the potential for fire, explosion, or environmental contamination. And remember, all three could happen at the same time. Process safety management involves a lot of different aspects, where competency of operators, understanding of control measures, risk control measures, understanding what to do in abnormal process conditions, safety critical maintenance are some of the key issues that must be managed by all employees and management. Now, one of the things I would like to mention, and maybe I'm preempting myself, is this is a taster session where I've just flown through every topic. Depending on the feedback, we would like to take this further and then have individual sessions on each pillar of compliance. So please, when you give us feedback, do tell us if you'd like some more of the same. There's a video which we'll try and sort out technical issues with, but basically this video is this poem, and it's quite a powerful poem. It's a poem by Don Merrill after an actual incident. And it goes, I could have saved a life that day, but I chose to look the other way. It wasn't that I didn't care. I had the time, I was there, but I didn't want to seem a fool or argue over a safety rule. I knew he had done the job before, and if I spoke, he might get sore. The chances didn't seem that bad. I had done the same. I had taken some chances. He knew I had. So I shook my head and walked on by. He knew the risks as well as I. He took the chance. I closed an eye. And with that act, I let him die. I could have saved a life that day, but I chose to look the other way. Now, every time I see his wife, I know I should have saved his life. That guilt is something I must bear. But it isn't something you need to share. If you see a risk that others take that puts their health or life at stake, the question asked or thing you say could help them live another day. If you see a risk and walk away, then I hope you never have to say, I could have saved a life that day, but I chose to look the other way. Thank you for your time. Over to Simon.
Okay, Shailesh, thank you very much for that. I've got a number of questions here. Some we've received directly from the people, so I'm going to read through them with the time we've got left, and obviously any that we don't get the time to go through, we'll make sure we answer in what is then posted online. So the first one is at the top of the list. I think it's the one that's come in most recently. The delegate apologised if you mentioned this earlier, but which of the PSM standards are more widely used in the UK?
In the UK, we tend to use the Energy Institute Process Safety Framework.
Okay.
And there is a lot of guidance on the HSE website under COMA regulations, which then mentions different standards.
Okay.
We obviously don't use the OSHA one, but
Yeah.
they're very similar.
Okay.
The elements are very similar. OSM has 11 different or 12 different elements, but we covered some of the elements within one of our pillars.
Okay. Okay, thank you for that, Shailesh. The next one, and it touches on one of those, it's one of these subjects that when I hear the two words put together in the same sentence, I get the hairs on the back of my neck stand up. Change management. And you mentioned that earlier about the importance of it and how not many people do it right, and I absolutely agree with you on that one. Is there anything, certainly in the process safety world, any guidance on that the delegates could have a look at, even if they're not in the process safety world, that actually maybe there's some principles there that they could be looking at tying into their own system?
Yes, certainly. I think most regulator sites, and I can mention the HSE, has got good guidance on them. And there's also a very good book by the American Chemicals Society, CCPS, Guidance for Process Safety, Center for Chemical Process Safety. That's specifically on management of change.
Okay.
It's a very good guidance and can be used. You might have to download or purchase it.
Okay.
And
again,
the Safe Work Australia, Canadian Occupational and Process Safety, there's a lot of guidance available. And the thing to do is not to make it overcomplicated so that people find it difficult to follow. What you should do is keep it simple, stupid, as they say. Yes, I like saying these cliches because they're great.
I thought when you said stupid, you were talking directly to me then, but okay.
No, never.
The next one, you talked about maintenance schedules,
Yeah.
and obviously the use of them and the need for them in process safety. I'm kind of adding my thoughts into it here, but I'm guessing the building of your maintenance system, you're probably going to tie that into the HAZOPs that you do to identify the critical elements of your plant to help prioritize.
Yep.
Is that right? Could you embellish on that a bit more? Your own approach to maintenance schedules and how you would build them?
For us, first thing we've done is we've taken the human element of guesswork out by having a structured, specific software. And there's lots of software available from different sources. And what plant preventive maintenance does is, first of all, it accesses your asset register. You know exactly what you have. And then you build in routines into your maintenance system. The software allows you to put in procedures. So, and these procedures should be taken from the design and operation guidance, which is supplied with your equipment. So for example, if you have a pressure vessel, the pressure vessel then will say, this is my design pressure. I should be tested every 3 years using this standard method. So there's no variation, there's no guesswork. So that is the approach I would take for preventive maintenance regime. So it's identify your assets, put them electronically, and then institute checks. Now, doing more of maintenance is not necessarily good. It should be risk-based. And again, on the HSE website, if you Google search, you will find risk-based inspection, and there's a lot of information. Fortunately, we now live in an age where information is not restricted to paper copies. Everything is there.
Yeah.
Google tells us.
And I guess being risk-based, that's where your HAZOP comes in, and that it's going to identify and help you prioritize. Yeah,
that's right.
Fantastic. We've got another question come in. Just any guidance on is there any guidance on the approach to develop and introduce PSM in a company where this would be a new concept?
Yes, Energy Institute Process Safety Framework is a very good document to refer to, and I shall provide a link to that.
Okay.
And some of the publications within those are chargeable, but most of it is sort of freely available to public. Within this, they've taken each element of process safety and given more detailed guidance. So you have the overall framework, and then you can go into each element. One such example is safety critical, identifying your safety critical equipment, and then it tells you what to do about it once you identify it.
Yeah. Okay. Fantastic. Another thing that you mentioned this, and it's obviously quite a hot topic for us in the offshore world, was the emergency plans and the testing of emergency plans. Obviously, in the offshore world and the marine world, that's something that we're required to do and required to test. And I'm just wondering, from a personal perspective, what that looks like in the onshore world, and how often you have to do it. Is that driven by external factors, or is that something that you determine for yourself? Or
Yeah, the external emergency plans are statutory requirement every 3 years, but internal emergency plan is left to the company's own devices. So you look at your hazard and see, have you got a sense of disquiet about it? Then you do it more often.
Okay.
What you also do is it should be proportionate to the hazards you hold. For our sites, which are just basic storage and transfer of fuel, it's different from, say, a pharmaceutical site, which holds highly toxic chemicals and intermediates.
Sure.
For them, the internal emergency plans are really critical because the first effect would be on the people nearby. If you take Bhopal tragedy, for example, there, the release of methyl isocyanate killed so many people and it went off-site as well. Over there, for them, doing those scenarios, even if it's just a couple of hours, you just grab people at random and say, I've just got this scenario, I've lost this toxic chemical. What's the thing you're going to do? Just very simple. And that should be good. And for further guidance, again, there is specific guidance by the HSE on emergency plans.
Okay.
I shall put in a reference for that.
Great. Brilliant. Thank you, Shailesh. We've got another couple of questions come in. Next one, what defines safety critical equipment under COMA?
Under that, if that's an equipment, the failure is one of your major accident scenarios. That's safety critical equipment. So take, for example, a very simple approach would be, if you have bulk tanks and there's a level gauge on it, that's a safety critical, because all your response is your last layer of protection. When the level gauge, if that level gauge fails, you are likely to have an overfill scenario that might lead to, if it's a toxic or very highly flammable liquid, a fire scenario.
Okay.
So that would be, so if you take the classic Buncefield example, the failure of the level switch led to the fire and explosion. We were very fortunate that no one was killed. Had it happened not on a Sunday morning, early in the morning, had it happened during peak time, there were thousands of residents and offices nearby, and you've seen the devastation. Just
Absolutely.
Look up Buncefield and it tells you. So that is an example of safety critical equipment.
Great, thank you, Shailesh. The next one, what models or tools have you seen that help to summarize the vast amount of data on process safety health status to senior management whose time is precious, that helps them understand where to allocate the resources? I guess that's a great question, isn't it? That you know, we as safety professionals, we love to talk about, we love to have lots of data, don't we, and spreadsheets and charts. But obviously, the people that we're presenting that to, they have a very short attention span occasionally, and a very short amount of time to consider it. So, what tools or tips would you give for that?
That's pillar 9, process safety performance indicators, and HSD 254 is a Bible. I really like that publication because it lays it out right from beginning about what it's about to the final summary. Now, there are companies, for example, Scottish Power, they have got a very elaborate PSPI tool, which is software and it's wonderful, and it throws a lot of attention to you. But there's nothing stopping you, a medium or a small size company, from developing a spreadsheet, which then month on month is reviewed at the board meetings. It will only take, say, 15 minutes, and it just gives you a red, green, or blue status. So, sorry, red, green, and yellow status. Yeah. So red means the trend is downwards. So that then flags up the senior management's attention. Why is, just as a classic example, why is the pipeline inspection falling behind? It's so critical to maintain this pipeline, which contains high pressure, toxic, corrosive fluid. So that is a key initiator of a major accident on the site. So why are we not doing that? And that's the way to grab board's attention. Color coding, keep it simple and keep it focused. And the other thing which many companies do go down at a tangent with is process safety performance indicator, maximum should be 6 to 8. In a very complex refinery business or offshore business such as yours, I understand and appreciate that you could have lots of key hazards and key indicators. So the one way to do would be to rotate. Look at, say, you choose first 6, look at that over 3 months, and you see there's no difference. Discard them, start again with different ones. And that is the way you can break it down and keep it simple. Otherwise, process safety performance indicator report could be 20 pages long and no one would be looking at it.
Sure.
Except for the person who produced it.
Really good question from Rajesh. Are there any recognised training courses or diplomas as such on PSM?
Oh yes, if you are based in the UK, there's a gold standard process safety awareness course, and it's provided by Cogent Skills.
Okay.
And there are different levels. There is process safety for leadership, and I've done one of those, and this is very good. So Cogent Skill are a provider of training, but they don't actually do the training. They have quite a number of certified training companies and training providers. So that is something you could look at.
Yeah.
And there are process safety for operators. There's also a train the trainer course. So for a company with, say, number of sites, it's not practical to take everyone out. So what you do is you take usually people from assurance or maintenance staff, you train them to deliver the process safety for operators training. And I also understand that IOSH is working with IOSH to develop a course on process safety.
Okay. Rajesh has followed that up by saying, I'm guessing he's based in the UAE, in the United Arab Emirates. So
yes, IOSH.
IOSH.
Look out for IOSH. Look out for IOSH. But yes, there are courses which, again, US websites, Center for Chemical Process Safety, can also provide correspondent courses.
Okay.
And you can be certified.
Okay, fantastic. Thank you. Going on to, I think, the final question we've got on here, again, going back to the one we were talking about, indicators, the question simply being more leading or lagging indicators. So
it should be a proportionate mix for both. You can't just rely on leading, and you can't just rely on lagging. If you're relying on lagging, you're having too many incidents. So I would not advocate that one. So it should be a good mix of both. And again, what I would say to you is, if you had a process safety incident, and the process safety incidents are also defined in the American standard API 570. There is a tier 1, which is a major one. There's a tier 2, and there's a tier 3. So tier 3 is minor. So you could sort of monitor these sort of lagging indicators and comparing it and saying, okay, we had 3 tier 1s, then there is something definitely wrong. Or we had 20 tier 3s, but no tier 2s or no tier 1s. That's good. We are having minor, that's fact of life, that loss of containment will happen. But if you spill 1 liter of a non-toxic, non-hazardous liquid, that's different to 100,000 liters going down the river.
Absolutely. Fantastic. Thank you, Shailesh. I think that's all the questions we've got on things. So you can sit back in your chair now. I think I can only thank you from a personal level for that. Process safety is something that I came into this not as interested, I think, as all the other delegates, is not something I considered myself to be particularly strong in. So you've given me a great insight that on a personal level as much, and also obviously as the representative of the offshore group here today, genuinely appreciate you offering that to our members as well as your own. I think it's been a fantastic insight into what is obviously a very complicated but also, but like we were talking earlier, but something that a lot of us do without even realizing it's probably process safety.
That's right.
I generally appreciate your input on that, so thank you very much indeed. Just a few things left to say from a housekeeping perspective. I'm led to believe by Ben, my colleague to my left, that obviously the presentation will be available towards the end of the week. Hopefully by Friday at the latest, it will be available to you also, and that'll be available both on the Hazardous Industries and the Offshore Group intranet pages, so please keep an eye out for that. Just a couple of other things to say before we bring this to a close. This is, as Shailesh mentioned, this is the first of the seminars that we've done together. We're very hopeful of doing some more, and so please keep an eye on Connect. Please keep an eye on our mutual event pages just for the next ones that are announced as and when they're arranged. The Hazardous Industries Group webpage, I believe, is being updated as we speak, with their events page in particular, so please do keep an eye out for their events that I know they're planning currently. And from the Offshore Group perspective, our next event is on Monday coming, which is the 15th, and that's back in Aberdeen, where we're doing one on the life of a safety rep. Obviously, as our offshore members on the line will know, that it's been a very challenging time for the offshore industry. So we get the insight of 2 representatives from Step Change and their G18 Safety Reps Committee to come and talk about what it's been like for the last couple of years under very challenging conditions. So we have Shane and Dave from the G18 come along to do that. So obviously all are welcome. So if you're in Aberdeen, please do come along and say hello to us. I will be there myself and look forward to seeing you all there. And just to say also that the Offshore Group Annual Conference, we've now got a confirmation of the date. It's going to be in October, the 19th of October. It's going to be at the Discovery Museum in Dundee. please do keep an eye out for it. We'll be posting some details on that very soon. We've already got confirmations from a number of speakers, including representatives from the HSE and the HSL. So please do keep an eye out for that, and you'll see more communications over the coming weeks. All that's left for me to say is thank you to everybody for taking the time to dial in today. Thank you for everybody for raising the questions that you have. Thank you to Shailesh again for the effort he's put into the presentation he's done today, and to Ben and IOSH for facilitating this for us. And we look forward to seeing you soon. Thank you very much.